Welcome back to Healthcare for Teens, a channel dedicated to helping teenagers understand more about the different areas of healthcare. Today we have with us Dr. William Nelson, a professor of oncology and the director of the Cancer Center at Johns Hopkins. Dr. Nelson, thank you so much for being with us today.
Sure, it's great to be with you.
To start off this interview, I'd like to ask, when did you realize that you were meant to be an oncologist?
I'm not sure I ever realized it in that way. I had an odd journey into medicine, and I think it reflects the kinds of things that you become interested in when you're younger and how you navigate your way through life and acquire the kinds of skills and interests that lead you ultimately down the road that I took. I really was not that I thought destined to go anywhere near medicine when I was younger. Before I went away to college, I got particularly good at running very fast, kicking soccer balls, playing music in time, and singing on tune. Those were my major skills. And I went to college and played college soccer and these kinds of things. And I ended up majoring in chemistry, not for an earth-shattering life choice, but mostly because my girlfriend did. And actually, in college, I never took a biology course at all, really. And did a lot of things with mathematics. So I got into chemistry. I enjoyed physical chemistry, quantum mechanics, and that kind of stuff. Just thought it was interesting. And then I planned to, play soccer for a couple of years after college, just to say that I did it more or less, and then figure out something else to do. And it turns out that wasn't in the cards for a variety of reasons. I ran into someone right around the time I was graduating who offered me a job in a laboratory. And that person was a cell biologist, we would say, worked on cell structure and function, growing cells on, cell culture dishes and the like. And he was also a very focused dermatologist. He worked with children that had inherited scaling skin disorders called ichthyoses. Ichthyoses literally means fish. It looks like they have scale on their skin. And I enjoyed interacting with these kids. They were in clinical trials at the time. He was doing one involving retinoids to try and affect the differentiation of the skin to try and reduce the scale. And I uh, I was very impressed with these kids. I mean, they had a disorder that changed their appearance, and so you can imagine what that's like when you're younger. And they had a good sense by participating in the clinical trial. They're very informed. Um, they had hoped that this intervention might help them in some way. They were reasonably had a healthy skepticism. Other things hadn't worked that well, and but they believed very strongly that by participating, that whatever would be learned would be helpful to kids that came after them with the same kind of problem. And I was, moved enough to have an epiphany or whatever you want to call it, and you spoke to the person doing the cell. I want to do this kind of thing, do research and experimentation that can help people and change their lives. And I remember he said, well, if you're going to do that, you're probably going to have to go to medical school because that's the only way you can really do it. And so I, talked to the folks that help you apply. And nowadays, I think kids can go back and address some of the course materials that they hadn't taken before. When I did it, that wasn't the option that it is now. So I said, look, here's the good news, which is also the bad news, is that your application isn't going to look like anybody else's in the stack. So some places may find that interesting, others may not. And so and that turned out to be the case. And so I ended up coming to Johns Hopkins. Actually, it's a great place, and was in the program. I always wanted to be a researcher as a physician, so I was in a program where you got an MD and a PhD together. And I think as you began to look around the various career options in medicine, they're very different. Whether you want to work with imaging or pathology or psychiatry or surgery or something like that. And I was attracted to medical oncology because there was a lot to be done. It's a serious collection of illnesses, particularly at that stage. They tended to be life-threatening, and there was an urgent need to improve treatment and a willingness in terms of the field, if you had responsible ideas, to be able to take them into the clinic and try and explore them and improving them with patients as partners. So that's how I got into this business.
What exactly does an oncologist do?
So a medical oncologist, what I am, uses systemic medicines, antibody drugs, small molecule drugs, other kinds of things to treat cancer when it's disseminated throughout the body. So,
What are the most common types of cancer?
to look at cancer in this part of the world, in this country, a couple of interesting features. So 80% of all cancers are diagnosed above the age of 60, 30% above the age of 80. Most common cancers in this part of the world are breast cancer, prostate cancer, lung cancer, and colorectal cancer. That counts for 80% of all cancers. So that's most of the disease burden in this country. The good news is that most of it's improving. 1991 was the year of the peak in what we call age-adjusted cancer mortality. That's the propensity for someone to die of a cancer at any given age. Gets around the aging of the population in terms of a scorecard. So that has fallen ever since. There's an estimate that probably, if you'd just followed those projection lines, that probably 3 million lives have been saved, something like that. And treatment's improving. So there's a couple of cancers that are on the rise. Pancreatic cancer, liver cancer are on the rise. No one really knows exactly why, but the other cancers are declining. So it's good.
How do you diagnose and treat cancer?
There's two sort of general ways. One is through some sort of screening, particularly for the common cancer. So there's mammography, which is a breast imaging tool used to screen for cancers, cancer precursors, and suspicious areas that can be biopsied. A biopsy is you remove a little piece of tissue or some cells so you can look at them under the microscope. A pathologist is the one who looks at them. A pathologist making a diagnosis is sort of required to establish a diagnosis of cancer. There's prostate-specific antigen, which is a blood test, PSA kind of screening for prostate cancer. If it's abnormal, get an image and a biopsy may be diagnosed prostate cancer. There's CT scans or CAT scanning, if you will, screening for lung cancer, particularly among heavy smokers. If they find an abnormality, they can biopsy it and make a diagnosis of cancer. You can screen for cervical cancer. You can screen for colorectal cancer. So there's screening things in play for the most common cancers and several others. The other side of that is that you'll be evaluated for some kind of symptom, so a pain somewhere, a lump or bump somewhere, or something like that. And then you're subjected to an evaluation. What's that lump or bump from? What's the discomfort from? And then in that process, you can make a cancer diagnosis.
How much, if at all, does AI impact the field of oncology?
So there has historically been a lot of machine learning and artificial intelligence tactics applied to cancer problems. Probably the two areas that are the furthest along, I would argue, one is in imaging, where you can use CT scanning or other kinds of imaging, train the AI tool to distinguish between some sort of abnormality or not, a screening abnormality or the like. The other is pathology, which is another version of imaging. There are already some tools that can aid in helping the pathologist predict who's going to have a more aggressive cancer, might need more treatment, or a less aggressive cancer might need less treatment. There have been some applications of AI tools in genomics. All cancers are fundamentally acquired, or the result of acquired defects in genes or gene function. All of them are. And so you can get a sense for an inventory of which genes are defective using DNA sequencing kinds of approaches. So as if you look at all those sequencing kinds of abnormalities, you can begin to, again, train AI tools to make predictions and make diagnoses and the like. So there are significant attempts to use AI tools to drive treatment decisions and whatnot. IBM Watson was a good example of something like that.
I learned that cancer is the second leading cause of death worldwide. Will this change anytime soon?
Yeah, I think it'll probably become the leading cause of death, which is not good news. I think the interesting thing is a few years ago, I don't honestly remember exactly when, but it was on the order of a decade ago or so, Cancer and cardiovascular disease became the leading cause of death, outpacing infectious diseases. And that probably got, you know, uh, some alteration in that with the pandemic over the last few years. There was definitely some increased mortality associated with the SARS-CoV-2, COVID-19 kinds of infections. But chronic diseases are fundamentally diseases of behaviors. So cigarette smoking, it's an addictive behavior, if you will. Another one is the dietary kinds of things. Many people look at it in terms of the social determinants of health. Where do you live? What do you eat? What kind of life do you live? So things like energy balance, the dietary patterns that people have, cigarette smoking, and by the way, it turns out these social determinants of health in this country were pretty tightly correlated with who got very sick with the SARS-CoV-2 infection versus who was able to, despite getting sick, sort of fight the infection off. So these social determinants of health throughout the world are probably underlying the cancer, cardiovascular disease, and some of the mortality associated with infections like the SARS-CoV-2.
What areas of research are you involved in?
So I was a laboratory-oriented genitourinary oncologist, able to do that by focusing on a smaller slice of overall medical oncology. Genitourinary oncology focuses on cancers of the kidney, the bladder, the prostate, and the testes. I can tell you prostate cancer was a very large incidence disease. While I was still more actively practicing cancer medicine, I became more or less a prostate cancer medical oncologist. But with that footprint, I was actually a laboratory-oriented researcher trying to build new tools for prostate cancer detection, diagnosis, prevention, and treatment. Was able, for instance, to have some fun experiences. Was able to be one of the investigators on the first clinical trial involving human gene therapy, which we did to construct cancer vaccines for kidney cancer out of the person's own cancer. Was able to make discoveries related to epigenetic defects in prostate cancers, most common one actually. You can detect that by assays and DNA, not unlike you can get a hair follicle at the crime scene. You can find the DNA associated with prostate cancer wherever you want to look for it. And that has become a tool that's used to aid in prostate cancer diagnosis. So that kind of thing.
Last but not least, what advice do you have for young people that aspire to become medical professionals?
Yeah, I think if you look at medicine and a number of other careers, I think the science, technology, engineering, and medicine careers generally, I think the world's moving more directly towards measurement sciences, making inferences with some degree of precision, looking at the distributions. If you look at height or something, it's distributed. If you look at blood pressure, it's distributed. So getting some sense of mathematics, statistics. I think we're going to see more and more measurement science being used to aid in medicine. And I think that's sort of where medicine is going. And you have to be able to approach that by remembering that people, when they're diagnosed with significant illnesses, cancer is a very good example. People are scared, so you need to apply these tools, the technology tools, the measurement science tools, apply them in a way that's sensitive to their wants, needs, and fears, and their family and their communication, their dignity as a human being, this kind of thing. So.
That's it for this video, and Dr. Nelson, thank you so much for the opportunity to interview you.
Sure. Good to be with you today.